everything we've done so far, we did to the target. But here's a secret the best hunters know. A huge amount of a company's most sensitive information isn't on their servers at all. It's leaked, scattered across the public internet, in search engines, in code repositories, in old archives, and in data breaches. And you can collect all of it without sending the target a single request. This episode is OSINT and Google Dorking, turning the entire internet into your Recon tool. Passive, invisible, and often the most valuable intel you'll ever find. Let's go hunting in the open. Quick living. Last episode was on target. You fuzzed live hosts to find hidden pages. This is the opposite, and it's completely off target. OSINT means you never touch the company's systems. You only query third parties, Google, GitHub, archives, beach databases. That makes it totally passive and essentially invisible. No firewall sees you, no rate limit stops you. You're just reading what's already public, and you'd be amazed what's public. So what is OSINT? It stands for Open Source Intelligence, and it simply means gathering information about a target from publicly available sources. Not secret hacking, just knowing where to look and how to search. The internet is full of a company's footprints, index pages, leaked files, developer mistakes, archive versions, exposed devices. OSINT is the discipline of systematically collecting those footprints into a picture of the target. And your first and most powerful OSINT tool is one you use every day, a search engine. Google is not just for searching, it's for hacking, when you know the advanced operators. This is called Google Dorking or Google hacking. Google has crawled and indexed billions of pages, including ones a company never meant to be public, exposed files, login portals, configuration pages, directory listings. Normal searches won't surface them, but special search operators will point Google straight at them. Learn a handful of these operators, and Google becomes a precision recon weapon. Here are the operators that matter. Site : followed by a domain restricts results to just that target. Inurl : finds a word inside the URL, like inurl : admin to find admin pages. Intitle : searches page titles, perfect for finding directory listings with intitle : index of. Filetype : finds specific file types. Filetype : SQL. Filetype : env. Filetype : log. Intext : searches the page body for a word like a password. A- sign excludes terms, and quotes force an exact phrase. Combine these, and you can ask Google very pointed questions. Let's see the killer combinations. Site : target.com, filetype : SQL, hunts for exposed database dumps on the target. Site : target.com, inurl : admin, finds the admin portals. Intitle : index of, followed by backup, surfaces open directory listings full of files. Filetype : env, intext : password, finds environment files leaking credentials across the whole internet. There are entire databases of these docs, like the Google hacking database, thousands of pre-built queries for finding exactly this kind of exposure. Copy, paste, and hunt. Now the developer goldmine GitHub. Developers accidentally commit secrets to public repositories constantly, then try to delete them, but the history remains. So you search GitHub for your target's name or domain, combine with dangerous words, password, API_key, secret, token, connection string. Search for the company's internal email domain in code, and you'll find configuration files, deployment scripts, and hard-coded credentials that were never supposed to be public. GitHub Dorking has led to some of the biggest bug bounty payouts in history. People leak keys. You just have to look. Searching by hand works, but you can automate it. Tools like trufflehog and gitleaks scan entire repositories and their full commit history for secrets. They know the patterns of API keys, tokens, and private keys, and they'll flag them automatically, even ones buried in a commit from 3 years ago that the developer thought they deleted. Point trufflehog at a company's GitHub organization, and it will surface live, valid credentials. A single leaked key can be a critical finding, and this is how you find them at scale. Next, a time machine, the Wayback Machine, at archive.org. It has saved snapshots of billions of web pages going back decades. Why does this matter? Because a company's website today is not the website from 3 years ago. Old versions contain endpoints, parameters, and pages that have since been removed from the live site but often still work on the server. So you browse the target's history in the Wayback Machine, and you find forgotten API endpoints, old admin pages, and parameters that current recon would never reveal. The past leaks the present's secrets. You won't click through the archive by hand. Tools like GAU, which stands for Get All URLs, and waybackurls pull every single URL a domain has ever had from these archives. in seconds. One command and you get a massive list of historical paths, endpoints, and parameters. Filter that for interesting extensions and parameters, and you've got a target specific word list and a list of forgotten endpoints to test, all harvested passively from the internet's memory. Now for the infrastructure side, Shodan, the search engine for internet connected devices. While Google indexes web pages, Shodan scans and indexes servers, services, and devices themselves, their open ports, their software, their banners. You can search Shodan for a company's name or IP range and instantly see every exposed server they have, databases with no password, admin panels, forgotten dev boxes, industrial systems. Census is a similar, powerful alternative. These tools show you the target's exposed infrastructure that a normal web search completely misses. Here's a clever Shodan trick: Favicon hashing. Every site has a little icon in the browser tab, the favicon. You can take the unique fingerprint, the hash, of a target's favicon and then search Shodan for every server on the internet serving that exact same icon. This uncovers hidden infrastructure, staging copies, forgotten servers, and internal tools that share the company's branding but were never linked anywhere. One little icon can reveal an entire hidden estate, a sensitive but important source: data breaches. Billions of usernames and passwords have leaked in breaches over the years, and that data is searchable. Services like Have I Been Pawned tell you if an email appeared in a breach. Others let you search across breach data, and here's the critical ethical line: you use this to understand exposure and report it, never to actually log in with someone's leaked credentials. Knowing that a target's employees reuse breached passwords is valuable intelligence. Using those passwords to break in is a crime. Stay on the right side of that line. Even the files a company publishes we can tell in their metadata. Every PDF, Word document, and image contains hidden data: the author's name, the software and version used to create it, and sometimes internal file paths and usernames. A tool like exiftool reads all of it. Download a company's public documents, run exiftool, and you can harvest employee usernames, discover their internal software versions, and even map internal folder structures, all from files they intentionally published. The document is public. OSINT isn't only about machines, it's about people, and this is where you tread carefully. Public profiles on sites like LinkedIn reveal a company's technology stack, from job postings, the format of their email addresses, and the names of employees, which matters later for testing things like login systems. This kind of people-focused recon is powerful and completely legal when it's public information used within an authorized engagement. But respect privacy, stay within scope, and never cross into harassment or social manipulation of individuals without explicit authorization. Like all Recon, OSINT is continuous. New leaks appear every day. A developer commits a key this afternoon, a new document gets published, a fresh breach drops. So set up monitoring, alerts for your target's domain on GitHub, save searches on Shodan, and automated dork checks on a schedule. The hunter who's watching when a secret leaks is the one who reports it first and gets paid. Passive recon never sleeps, so neither should your automation. Let's tie the toolkit together. Google Docs and the hacking database for exposed files and portals. GitHub plus trufflehog for leaked secrets. GAU and the Wayback Machine for forgotten endpoints. Shodan and Census for exposed infrastructure. Exiftool for document metadata. Breach data for exposure carefully. Everything you gather flows into one intel file on the target, and not one byte of it touched their servers. That's the power of OSINT: maximum insight, zero footprint. A serious word because OSINT blurs a line. Reading public information is legal. Acting on it can be a crime. Finding a leaked password is intel, using it to log in is unauthorized access. Finding an exposed database is a finding, downloading its contents is theft. The rule is simple: collect and report, never exploit beyond your authorized scope. Responsible hunters find the leak, prove it exists, and tell the company so they can fix it before a real attacker does. Stay passive, stay legal, stay ethical. Why does OSINT matter so much? Because it finds what active scanning never can. No amount of fuzzing a live server will reveal an API key, a developer push to GitHub, or a database dump indexed by Google, or an endpoint that only exists in a 5-year-old archive. These are some of the highest value findings in the entire field, and they're sitting in the open, free, invisible, waiting. The best hunters aren't just good at attacking targets. They're brilliant at reading the internet. OSINT is gathering intel from public sources with zero requests to the target. Google Docking with site filetype inurl and friends surfaces exposed files and portals. GitHub plus trufflehog finds leaked secrets. The Wayback Machine and GAU recover forgotten endpoints. Shodan maps expose infrastructure. Exiftool mines document metadata. Monitor continuously and above all, collect and report, never exploit. Maximum insight, zero footprint. Screenshot this. You've now mapped the target from every angle on it and all around it in the open. That completes your reconnaissance foundation. Next episode, we start turning recon into attacks, beginning with fingerprinting, identifying the exact technology and version behind every target, using tools like WhatWeb and Vapalizer, so you know precisely which known vulnerabilities to aim at. Subscribe so you catch it. And tell me, what's the wildest thing you've ever found with a Google Doc? In the next one.